Section 6.6 Phase shift sinusoidal curve fitting. So sinusoidal curves are modeled by this equation y equals a sine omega x minus phi plus b. Phi is a Greek letter. A specific case of this is y equals a sine omega x, where omega is bigger than 0. The amplitude here, we find the amplitude is how far up and down this can go. It's the absolute value of a. The period is 2 pi over omega, we call it t. So then usually we take the period from x equals 0 to whatever that t is. So if the period is 2 pi, we go 0 to 2 pi. If the period is pi, 0 to pi. So back to this curve here. And what we do is, if we start back to y equals a sine omega x minus phi, factor omega out. I know there is no omega in the phi term, but we can still pull the omega out. That gives us x minus phi over omega. If you set that highlighted part equals 0, or the period itself, what do we get? X minus phi over omega is 0. X minus phi over omega is 2 pi over omega. Then, if we solve for x, we get x equals phi over omega, or x equals phi over omega plus 2 pi over omega. So the period is going to go from phi over omega to phi plus 2 pi over omega. That's where the period is going to go. Why do we need to know this? Well, because we're going to look at more complicated sine functions to be graphed by hand. So these procedures will help us. That phi over omega has a specific name. We'll see it in a minute. So now from the graph of y equals a sine omega x, using transformations, we may shift the graph of a sine omega x, phi over omega units to the right if phi is positive, or to the left if phi is negative. So that phi over omega is called the phase shift. It's called the phase shift. And in general, for the graphs of y equals a sine omega x minus phi and or the cosine one, where omega is positive, we have three things. The amplitude is still the absolute value of a, the period is 2 pi over omega, and the phase shift is phi over omega. If we look at this one, we need to graph this one, 4 sine 3x minus pi. First thing we find its amplitude, which is the absolute value of 4 is 4. The period is 2 pi over omega, which is 3. So that's t, the period. And we have to find the phase shift. So what we can do, we can factor the 3 out. Here omega is 3. We factor that 3 out. And then we get x minus pi over 3 equal to 0. So the phase shift is pi over 3. So the cycle is going to start at that 1, the pi over 3, and ends at phi over omega plus 2 pi over omega. So it's pi over 3 plus 2 pi over 3, which is pi. So we're going to graph the function from pi over 3 to pi. Pi over 3 to pi. Next. So that tells me the beginning and the end of the cycle, of one cycle. So how are we going to graph it over pi over 3 to pi? So I start with the number line. I'm going to go pi over 3 to pi. We always have 5 points. I need to fill out this. The first thing we do is get the middle one, halfway between pi over 3 and pi, by adding the two numbers up, pi over 3 plus pi, and divide by 2. So when I did that on the right side, I get 4 pi over 6. 4 pi over 6. So you may leave it like this, and to get a pattern here, what you can do is convert this to the same base. So multiply top and bottom by 2. So 2 pi over 6. This is 6 pi over 6. So you can see there's a 2 here. Then I'm expecting this to be 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. So the pattern keeps going on and on. 2, 3, 4, 5, and 6. These are the 5 values we get. Now we can substitute them back in if we want to do so to get the graph. So at pi over 3, if you substitute back, you get 0. At pi over 2, which is 3 pi over 2, this is pi over 2, 3 pi over 6, it's 4. 2 pi over 3, this is the 2 pi over 3, that gave me 0. The 5 pi over 6 gave me -4, and the pi gives me 0. Then I connected, I got this. So I graphed it only over one cycle. So here I show you the values I substituted in. When I substituted pi over 3, what I got, the 3 cancels, so you get 4 sine 0, which is 0. You get 4 sine 3 pi over 2 minus pi, which is 4 sine pi over 2. And that gives me, sine pi over 2 is 1, that gives me 4. If you substitute 2 pi over 3, the 3's cancel. You get 4 sine pi is 0. 5 pi over 6, it gives me -4, and pi gives me 0. So that's where these values came from. And then I substituted or plotted them on the graph to get what I need. As another method to graph this one, we can graph it using transformations. So if we look at the function y equals 4 sine 3x minus pi, we can start by graphing 4 sine 3x or 4 sine x or sine x. You can start anywhere you like. So let's say using transformations to graph this, I started with y equals sine x. That's what we call the parent function, y equals sine x. So we are all familiar with the graph of y equals sine x. Then we graph 4 sine x. And how do you do that? We just stretch it up vertically by a factor of 4. Instead of going from 0 up to only 1, we go 0 to 4. So that's a vertical stretch by a factor of 4. Then there is a 3 here, 3x. So what the 3 tells us is kind of like we replace x with 3x. This gives me a horizontal compression by a factor of 1/3. Horizontal compression by a factor of 1/3. Next, 3x minus pi, we factored the 3 out, and now x minus pi over 3 tells us to do a shifting to the right pi over 3. So shift the graph that we obtained in step 3, pi over 3 units to the right, pi over 3 units to the right. So let's do it on the graph, which I already did, but I'll just explain the difference between them. So the first curve we started with is the black one. This is the y equals sine x. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. Then the next one I graphed is the 4 sine x, which is the green one. So the green one, y equals 4 sine x. So 4 sine x, what happened is we just stretch it up to 4, the black one, and then down to -4. After that, in step 3, we graphed the blue one, which was a compression, a horizontal compression. So instead of going all the way to 2 pi, it went only up to 2 pi over 3. So if you look at step 3, was a horizontal compression by a factor of 1/3. So the 2 pi becomes 2 pi over 3. Just multiply everything by, so the pi became pi over 3. The 3 pi over 2, if you multiply by pi over 3, became pi over 2. So that's what happened. The 0 stays the same. The pi over 2, if you multiply by 1/3, becomes pi over 6. That's where that came up to, this point. The pi became 3 pi, the pi over 3, that's where it became, and then the other one's the same. So we get the blue one. Then the last one, we just shifted everything to the right, pi over 3 units. And the easiest way to do that is take the x values for the blue curve. So the blue curve had 0, pi over 6, pi over 2, actually pi over 3, pi over 2, and 2 pi over 3. So now what we do is, when we say shift it to the right pi over 3, add pi over 3 to each one of them. So I add pi over 3 to this, 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 add pi over 3 to this. So the 0 became pi over 3, so that's where the addition was performed. Add pi over 3 to each one of them. And we got these numbers: pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. So that gives me the orange curve if you plot them. So the y coordinate stays the same. Y values stay the same. We don't make any changes with the y values because we're shifting to the right side. So the y stays the same, only the x changes.